When we think of cold, we usually imagine the frozen places on Earth. The icy winds of Antarctica, winter nights covered in white snow, or distant planets, far away from the sun. But all of that cold is still nothing compared with one special place in the universe. A place so cold that it almost touches the final limit of temperature. A place where even deep space itself is warmer than it is. That place is called the 𝘚𝘐𝘐 Nebula. A strange cloud of gas located about 5,000 light-years from Earth. In the constellation Centaurus, from far away, it does not look like a deadly place. It looks more like a faint cosmic cloud. Cold, quiet, and almost unreal. But hidden inside that delicate beauty is an incredible record. The 𝘚𝘐𝘐 Nebula has a temperature of only about -272°C. That is just about 1 degree above absolute zero. And to understand how terrifying that is, we need to know what absolute zero means. Absolute zero is the lowest possible limit of temperature in physics. It is the point where the thermal motion of matter almost drops as low as it possibly can. In simple words, the hotter something is, the faster its particles move. The colder something is, the slower those particles become. And when something gets close to absolute zero, everything seems to fall into the deepest stillness matter can ever reach. Not the silence of an empty room, not the silence of a late night, but the silence of the tiny particles themselves. The particles that make up matter, a cold, almost absolute, a state where motion itself seems to be squeezed to its final limit. What makes the 𝘚𝘐𝘐 Nebula even stranger is that it is colder than the background temperature of the universe itself. After the Big Bang, the universe was left with a faint glow called the cosmic microwave background. It is everywhere. Like a very thin trace of warmth left behind from the earliest age of the universe. That background radiation has a temperature of about -270°C, which means that deep space itself is already unimaginably cold. And yet, the 𝘚𝘐𝘐 Nebula is even colder than that. It is almost like a special pocket of darkness, where the cold goes beyond the natural cold of the universe itself. And that leads to a fascinating question. How can any place in the universe become that cold? The answer begins with a dying star. The 𝘚𝘐𝘐 Nebula was formed by an old star, a star that is reaching the final stage of its life. As that star slowly dies, it throws matter outward into space at enormous speed. Layer after layer of gas is pushed away. It expands rapidly. It spreads out into the surrounding void. And when gas expands that quickly, its temperature drops sharply. You can picture it like gas escaping from a spray can when compressed gas is suddenly released and expands fast. It becomes colder. But in the case of the 𝘚𝘐𝘐 Nebula, this happens on a cosmic scale. A dying star is blowing away its own outer layers, and that final breath has created one of the coldest places humanity has ever known. The 𝘚𝘐𝘐 Nebula is not terrifying in the way a black hole is. It does not swallow light. It does not tear matter apart with overwhelming gravity. It does not erupt like a violent supernova. It is frightening in a different way. A quieter way, a colder way, and a lonelier way. Out there is no familiar warmth, no brilliant light from a young star, no life as we know it. There is only gas, still expanding. Only matter being cast away from an aging star. Only a cold, so close to absolute that it wraps itself around that distant region of space. If a black hole is the symbol of darkness, then the Boomerang Nebula is the symbol of ultimate cold. A place where the universe seems to slow down, a place where the motion of matter is pulled close to its lowest possible limit, a place that reminds us the universe is not made only of bright and beautiful things, not only stars, galaxies, planets, and giant explosions. It also contains places that are silent in a deeply unsettling way, places so cold that everything seems frozen inside a vast and endless stillness. And yet, places like the Boomerang Nebula help us understand the universe more deeply, because it is not just a cold cloud, it is a moment in the life cycle of a star. A star is born, it burns for millions or even billions of years. Then slowly, it begins to run out of fuel. It swells, it sheds its outer layers, and in the end, it leaves behind a cloud of gas that is beautiful but hauntingly cold. So the Boomerang Nebula is not only a story about cold, it is also a story about endings, about the slow death of a star, about the way the universe can turn decay itself into something strange, beautiful, and almost unsettling to behold. Some stars die in violent explosions. Some end their lives by collapsing into black holes, but others leave the cosmic stage by blowing out cold layers of gas, forming a faint cloud in the dark. And among them, the Boomerang Nebula is one of the most extraordinary examples we know. When we look at the coldest place in the universe, we are not just looking at a temperature record. We are looking at one of nature's extremes. We are looking at a region of space where cold almost reaches its final limit. A place colder than the leftover glow of the Big Bang. A place born from the final breath of a dying star. And that is what makes the Boomerang Nebula one of the strangest places humanity has ever discovered. It is not loud. It is not blindingly bright. It does not appear like a cosmic storm. But its existence alone is enough to leave us amazed, because somewhere out there, thousands of light years away, there is a region of space so cold that it almost touches the final boundary of physics itself. A place where even the darkness of the universe is not as cold. And maybe that is exactly what makes the universe so fascinating. It is always holding some kind of extreme that the human mind struggles to imagine.